Hey there, everybody. Welcome back. We're going to do a little bit more on recursive tracing because it's not the easiest thing in the world. So let's, what is it, lecture day 5, recursive. Hopefully that's not too long. I think I don't need the programming methods in there. That's extra labeling shit. Please don't make me try to talk over you. Please. All right. So let's get a file going. So CSCI 02, spring 2024, lecture day 5. Let's do the Pi app or the Pi lab. All right, so I'm gonna go get the get the instructions. Go over the module. Let's put this in. Whoa. I need some fucking returns in it. All right, there we go. So we're looking to do pi. And pi can be approximated with a series equation. Maybe let's go get the actual value of pi to several decimal places. That's enough. We don't need to try to get better than that. Plus more digits. Okay, so this is lab, what is it? Lab 2C, was it? 2B? 2C. One of the lab 2Cs. Recursive pi. All right, you guys with me? Let's get some shit set up. Using namespace std int main void return 0. Got a couple cout end lines in there because I hate having all the garbage on the end of the screen when I run it. Okay, so I got that set up. Let's hit the paper and figure out what we're doing here for pi. So I got my visualizer here. And it says pi equals 4 times 1 minus 1/3 plus 1/5 minus 1/7 plus 1/9 minus 1/11 plus 1/13 minus 1/15 blah 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 blah. Pi. Well, we definitely don't want to go through and enter that shit by hand. So we need to come up for a formula for this. So like this would be the first term, the second term, the third term, the fourth term, the fifth term, like that. So depending on where we stop adding, like if we only stop with one term, pi equals 4 is clearly nowhere close. Let's look at some iterations of that. Let's see how that's bouncing around. So we got 4 minus 1/3. So it says 3.667. Then we'll add 1/5. Oh, that looks shitty. Plus 1/5. So 3.667 was high. 1 divided by 5 should be even higher. Do I have the wrong thing? No, I have the right thing in there. Nope. No, I don't. This is 4 minus 4/3 plus 4/5, because the 4, if I distribute the 4, so plus 4/5 is, I think that it would have been lower. Let's do it a little bit. Okay, 4 minus 4/3 is 2.66, is too low. And then plus 4/5 is actually plus 0.8. I'll do that quicker. And then we've got minus 4/7. I'm not going to do that in my head very easily. That's too low. The 0.8 was too high. And when I add in 4/9, I'm probably going to be above it. God damn it. Answer. Why does that say plus 6 point? Let's go there. Plus 4. Plus 4 divided by 9. That's above it. So it's ricocheting around it. If we had like 3.14 here, the first term is too high, the second term is too low, and it's kind of bouncing around it. And it should narrow down on it, on the value 3.14. That's what it's doing. So like if I call this, what about the nth term? Let's see if we can find a pattern here. So first term is 4, or 4 over 1. Because I see fractions, so I'm just going to write it as a fraction. Second term is 4 over 3. The 4 on top isn't changing. Third term is 4 over 5. So maybe if we do something on bottom where we call this, like what would 4 over n be? If I did 4 over n, we'd have 4 over 1, 4 over 2, 4 over 3, 4 over 4, 4 over 5. It looks like we don't want all those. We want that one, and we want that one, and we want that one. If I said over 2n, I'd have 4 over 2. That's bad. We're only getting the even ones, but let's see what it would look like, because maybe we can adapt this. 4
2n minus 1 maybe.
So yeah, let's check that out. 2n minus 1. And we've got 4 over, so the first term, n equals 1 here. So 2 minus 1 is 1. And then n equals 2. I've got 4 over 4 minus 1 which is 3, 4 over 3. That's good. And then the third term, 4 over 2 times 3 minus 1. It's looking like 4 over 5. That's good. So we're looking at a 4 over 2n minus 1, but we also have these minus signs here. So the first one needs to be positive, negative, positive, negative, positive, negative. How could we make that?
You could make it so that the denominator of the entire fraction is multiplied by 1 every single time. So
By 1?
-1.
Okay. So -1. So if we do it every single time, we would need it like n times.
Yeah.
So when n is 1, this is the wrong sign. So maybe do n plus 1 or n minus 1. N minus 1. Let's give that a try. We're not even going to, oh shit. That cut off all the screen so you couldn't see it. I didn't want to do that. So let's try that here. We're not going to try to do the summation yet. Let's just do a for loop. N equals 1. N less than, I don't know, 8. N plus plus. We're going to see out. I don't want the decimal version. I want it written as a fraction. So we're going to do the, I'll do the -1 to the n minus 1 here. -1. I need maybe have C math in here, right? So this is telling me we're going to use powers, maybe include the C math library. So we'll do pow -1, comma, n minus 1. That'll give us our sign. Times 4. And then I'll make a fraction bar, which looks funny like that. That should show the, nope, that did look right. No, that's right there. And then we'll do the 2n minus 1, 2 times n minus 1. We'll put some spaces in there. We're just trying to see if we can get the values. So we got 4 over 1 minus 4/3, 4/5, -4/7. And this kind of matches up. Does it match up with what we had here? -4/3 plus 4/5. It looks like we got a good sequence here. So what we had written here was looking good. This looks like the right. Oh, shit.
I have a question.
Yeah.
So when we first did this last semester, I think it was for homework, we had the option of doing something like this or using recursion.
We're gonna do it recursively.
Typically, which one is better? Like, which one is like more efficient when it comes to like a series, like a power that I'm like this series?
This is probably faster this way. Well, it's less memory this way. But recursion is probably faster. It depends on the actual project. The bigger the project, the the less memory repeats you want to do, the trade-off is there. Every once in a while, the recursion's faster, but not often. So this is not recursion, right? This is not recursion. It's actually called iterative. We're doing it through iterations. So how could we set this up to do it recursively?
So you could set up like a, I don't know, you can make a function.
Let's make a function. Oh, we got to do a function for it to return, for it to do a recursive thing. It's got to have a function. So maybe recursive pi. How about rec pi? So that I'm not doing a lot. We don't actually, what kind of input should we have here? So what are we wanting to input? Then we'll decide, we're kind of wanting to put an n, right? How many terms we're doing. So maybe double is not the best choice. Let's go with n. So n, I'm going to call it n terms. That way it's descriptive. And nope, that's not how we code. We do the prototype above and we implement below. WTF. There you go. Okay, so we have n terms coming in. So let's say we're doing 10. Let's visualize what's going on here. So n equals 10. We're passing in 10. The first term is going to be, we have a 10. So we're going to do 4 over 2 times 10 minus 1 times -1 to the 9th. So we're going to have -4/19. And to do it recursively, this probably needs to keep dropping. So the next one should be n equals 9. So maybe we'll call this like sum. And we wanted to call the next step. So we wanted to call recur pi 9 should be the next one. So maybe do return, I'm off screen. What should we do? How should we set this up? This is going to do rec pi 9, then it'll be rec pi 8, then it'll be rec pi 7. Until we get down to rec pi 1, which seems like that's where we want to stop because putting in 0 doesn't mean anything. So maybe n equals 1 is our base case.
And then the rest are just taking care of that condition.
Yeah. So n equals 1 is the base case. Let's put that in here. So if n equals 1 comparator, we want to, the base case is just 4, right? The first term is 4. Return 4. I don't even need to, I can make a double term sum and say, we've got pow, we had all the stuff up there. Pow -1, n -1. times 4 divided, I'm gonna call it 4.0 to make sure it does double or double division. Divided by, we need parentheses, 2 times n minus 1. That's calculating it, and then I wanna, that's just doing the nth term. And then we wanna return sum plus rec pi. If we're doing n equals 10 and we want n equals 9, we should probably do n minus 1. Yeah. Right. You're right. So maybe we should change it to, the whole premise was off. I was only gonna get a 4 or a 3, wasn't I? That's fucking dumb. But we would have found that real fucking quick. One quick run. Thanks for saving me, whoever saved me. I don't see chat popping up. Is that just Juan doing it? Juan caught my error. All right. I'll comment that out. We don't need that anymore. Does that look good? Remember, since we're only doing the if state, we don't need the brackets and an else thing if there's only one line. Return 4 will end it right there, and it'll never see the rest. And if it's not n equals 1, it's going to skip right by this return and do the rest. So let's give that a gander. Let's see, what did I have on my phone? Which value did we go up to? I went up to 4. Let's see if we get the same thing as before. Oh. I don't. Oh, that's 5. That explains it. There we go. All right, so let's make this a little prettier. Finding pi recursively. Choose how many terms to use. The space in there will prompt for a CN, which means I need a variable. In N. CNN. So by choosing int n, no matter what they put in, it's gonna save it as an integer, even if it's a letter, it's not gonna look good, but do some. Then we want to do, we'll do rec pi n, but let's Let's do this. The new line in there. Put a tab in there so it looks pretty. Pi with n terms equals rec pi n. Everybody ready? I didn't see you on Friday. But not you?
No, what? No, it's not happening.
Is anyone gonna, did anyone sign up? From anyone that was there for FNL? You signed up already? Wonder how long it's gonna take to get that bus full. The NASA sign up started for Ames field trip.
Oh, the bus full.
Were you not in there for the NASA fucking permit?
Oh, no, not for that. I missed it. As soon as I went there, you like went up there.
Wait, say that again?
As soon as, as soon as you left, I had it right. And like, I just, like, you were there.
Do you know I left at 8:30?
No, like, you left, like, this week.
Oh. I'm like, I'm calling bullshit here.
No, I was there the entire night. As soon as you, like, I missed your speech.
You came in before. You were standing there. You fucking left during the announcements when I said there's a fucking major awesome announcements. You're like, nope, I'd rather go fucking play chess now that the food's here.
None of my officers were there, and I wanted them to like fucking clean up and I guess maybe.
He's the worst minion ever. All right, let's give it a run. The NASA Ames field trip.
Oh, okay.
We're the Mesa students. We're getting a bus to go on April 19th.
Did you sign up in FNL?
There's a sign up flyer, should be posted in FNL. And Mesa is supposed to be sending out the flyer too. It's got a QR code to scan. You do need to be, apparently you need to be an adult, 18 or older, and you need to be a US citizen.
Oh,
Well, it affects some people. I know, and because they're gonna want a valid email address and like, so you send, when you sign up, do your school ID or school email. Because they're gonna send you, like, once we submit the list of names and email addresses, they're gonna email you to say, do this activity to get like pre-authorization. And then when you show up, you need either your driver's license or your state issued ID. Yeah, they go through everybody one at a time. They're not letting anybody in.
your driver's license without having, like a speech or something. Like we made that law a couple years ago. So maybe. No, it's a real ID. Oh, the real ID? Yeah. Not the just regular driver's license? No. They're on it. I guess that makes sense. They're like near rockets and like kind of sensitive stuff. You don't want
Yeah,
some guy who says his name is Eric and
right.
Vladimir.
Well, they have like the wind tunnel there. Last time I was there, there's a Black Hawk. Hopefully you guys will get to go check it out and sit in it and see what it's like to sit in a Black Hawk.
Is that like a plane? I don't know what that is. I'll see myself out. I'll walk out.
Make sure you let the door hit you too. The fuck? It's a fucking helicopter. There's a goddamn movie called Black Hawk Down. He's the worst. That is not an excuse. I study a lot too. I wasn't studying that. I fucking played Power World for 12 hours on yesterday. Fucking, I just downloaded it on Saturday and I'm like, this is fucking fun. All right, let's see. Choose how many terms integers use. Let's do 10. 10 is garbage. That's fucking garbage. All right, fucking let's up it again.
Just like Monte Carlo.
So let's do 50. Getting closer. It's supposed to because it's doing this ricochet thing. Slowly, the alternating sequences slowly close in on the value. You know what? I'm tired of running that each time. So maybe we should put this in a loop. Boolean run again. Was yes. 1. 0 is false, 1 is true, right? Okay. Full running in equals 1. And then we'll put this in a do while run again. And we need to prompt, or do you want to run again? And I guess we need a char input. C in the char. That's not it. CN, I call it temp. If temp equals no, what's the or thing in this?
Double line.
Double vertical?
Yeah.
Just checking. See who remembered the good stuff. We will say run again equals 0. That's all we need. We set the default case to what is it not like? Oh, because I entered the string version. God damn it. Yeah. There we go. That should work, I think. All that to prevent having to run it a few times. We tried 50 and it was 3.12. What about 100? 3.13. Fuck, we're still not even accurate to 2 decimal places. What is this bullshit? What is this bullshit? I kind of want to add some more decimal places. So maybe we need to include IO manip. So we'll do fixed set precision. How many decimal places we want? 8. $200. MF. 500. Oh, look at this bullshit. 1,000. Well, we're getting closer. What is it? We're looking for that. We don't even have the 159 yet. Interestingly enough, we've got 059. Oh. Still not getting there. Fuck it, 3,000. Getting a little bit better. 6,000. Ah, what happened? I blew my stack. It fucking blew up. God damn it. Well, that's the faults of recursion sometimes. Apparently, this does not look like a good program for recursion. Unless you've got a hell of a lot more room on your memory than I do. Let's do a trace real quick, just to make sure it's working the way we want it to. Because that's what's going to be on your test, is how to do a recursive trace. So maybe we should do the fucking recursive trace on this. So where's my script here? So just real quick, rec pi n equals -1 to the n minus 1 times 4.0 divided by 2 times n minus 1 plus rec pi n minus 1. That's the return right there. In fact, we'll do a little bit of refactoring real quick. Let's get rid of the sum thing and just move that shit down there. Now we don't need all that. One extra line of code. So when we plug in n equals 10, so rec pi 10. Oh, fuck it. That's a lot of terms to do recursively. Let's do rec pi 6. So what we're doing is we've got n equals 6. So n does not equal 1. We go to the next part. We calculate it. It's -1 to the 5th, which is -1, times 4 divided by 2 times 6 is 12, minus 1 is 11. Plus rec pi 5, which calls n equals 5. N does not equal 1. -1 to the 4th, which will be even, times 4/9 plus rec pi 4. It's 4/9, right? We're sticking 5. 10 minus 1 is 9. Yeah. So rec pi 4 calls, we got n equals 4, which does not equal 1. -1 to the 3, 4/7 plus rec pi 3. Maybe we'll come up here, save some space. Again, not equal 1. So our exponent is 1 lower. And we're multiplying it by 4/5, right? Plus rec pi 2. So rec pi 2. N equals 2, which is not 1. So we got -1 to the 1 times 4/3 plus rec pi 1. So we got rec pi 1. N equals 1. So we got the base case. We're going to return, the base case was return 4. Go to a different color. All right, so we're returning 4. 4 comes up here. And we got 4 minus, because it's a -1 to the 1, 4/3. And then that one's done. And this returns that. So that brings this up to the next line. I'm writing over here down to the lower left. This brings this up. This pops off the stack. And now we're going to add -1 to the 2, which is positive, so plus 4/5. And we return this sum back. So that comes down here. We pop that off. And so that's the n equals 1, n equals 2, n equals 3, n equals 4. We're adding or subtracting because it's an odd exponent, 4/7 plus rec pi 2. I didn't write it very well. Or 3. And so that one gets returned. So we pop it off and goes back with that. And we got the n equals 5 term. -1 to the 4th is positive, plus 4/9. Whatever that sum is, that gets returned up here, pop off the stack. We're at n equals 6, our starting value. -1 to the 5th is an odd, so it's negative. 4/11. And whatever that value is, that gets returned to the main, and we're doing C out of that value. And the memory gets popped off. Now we saw that this formula doesn't work very fast because going to fucking 3,000 things still wasn't accurate to fucking 3 decimal places. So it's not a fast process. 103,000? How many decimal places was that accurate to?
It was 6.
6? 3.14159. 2, I think is the next one. Well, you can get more. You just got to do fixed set precision higher. You don't need long until you're going after what, 8 or 16 or some shit like that. So, recursive tracing.
You want us to like write out recursive tracing like this on the exam?
Yes. Now, as long as there's a flow chart, a good idea is to do the little boxes to indicate what's taking up memory, because each of those is a memory thing. Like on the test, the part where I'm going to want you to write it, it's not going to be fucking 10 long. It's 5 or 6. It's not going to be a long process. The idea is that you know how to do it because it helps make sure the code fucking works. Now I know, regardless of whatever I fucking coded here, I saw through my recursive trace that we had the right setup. because we matched the formula that we were looking for. So I don't have to trust that I didn't make mistakes. I know that I didn't make mistakes.
Redden had got me points because I did it horizontally, I was in vertical, and you like stressed it so much that you wanted it up, and I guess I didn't like, pay attention.
As long as I see a flow chart, I'm fucking happy. There will be like it'll be on paper, so like do what you gotta do. He was very anal. He wanted to like start at the bottom and work up and then pop off the stack and go downward because that's how stacks work. You put shit on top. Which is kind of good because when we start talking about stacks, it's handy to visualize that, but he didn't need to use the word stack here. But it is what it is. Pile. You put it on the pile. Any questions on that?
Yeah, one question.
Yeah.
It's not on the actual recursion itself, it's on the blue while loop. So why do you do it so that run again equals true instead of put up? You can save yourself a line of code just by putting that function in there. So saying run again equals, and then if it's y, like they can enter y or like the character y, capital or lowercase, and then do you want to run again?
Honestly, you don't even need the equal true, you can just leave it like that, and then reverse this one.
Because it just saves you space.
You're right. It's just more I'll run again. But okay, I'm going to show that both ways because our other option is having this. We had the curly brace and we had while, and Eli's suggestion just says while run again. Which one's easier for you to read as a human being? This one is technically true. You have to stop and fucking think about it unless you think in computer code a little bit too fucking much. But if we're interested in saving, I don't know if it's still doing the comparison. So we haven't saved any time or efficiency other than save yourself a few characters.
You could also do this too. Yeah, I mean that works too. You could also do something like this. This is something that I used last semester because I figured it was way quicker than the other method. Inside the while, you just say run again equals equal. You prompt the users like, do you want to run again? You want to run again? Yes or no? And if they put the capital or lowercase, it doesn't matter. I mean, it's the same thing. It's the exact same thing, but at this point, we're just arguing over semantics. It's not that important.
So yours required starting it off as a 0, right?
Yeah.
And they definitely had to do a Y or a. This one, as long as they don't do N,
It goes through.
it goes through. So there's two different ways. That's very valid. But it would just mean equivalently, if I wanted to do the same thing like you're saying, I could do CN temp, and then what we need to put here is while run again. I don't need the. So this is going away. So we're looking at refactoring right now. We're getting rid of that. So temp. Yeah, we're gonna have to change the sign, right? So we need to put, yeah, I know, I gotta cancel out the rest. And we don't need that now. What? You right? We're gonna refactor, let's refactor. Let's get this shit fucking streamlined. I like having that space right there. It helps make it a little bit easier to read as a fucking user. Don't need all that. We don't need all that. I do need something there though.
Because when you're running a bunch of like code, it helps if you shorten things just a little bit.
Right.
Otherwise you might get lost in the code.
This also has the advantage of telling the user what you're reading. The same thing with the temp equals true. Let's make sure the refactoring worked. I said no, and this motherfucker said, let's run again. So. I shouldn't have needed that. I shouldn't need a see and ignore but I'll do it. MF. So it must be with my logic gate. You think so? Likes it now. It didn't like it a second ago. Oh, this is that discrete math class helping you, isn't it?
Yeah.
Bam.
There you go.
What? Y'all know I never saw Chef Emerald Lagasse? Yes, call him. Yeah. So we don't need this part right there. All I did is took what I had put as the sum, and I instead where I had sum equals this, I just fucking eliminated the sum part and put it there. So where this can be more time saving or stuff like that, doing the comparisons each time takes longer than doing math operations. So comparators take longer than math operations. So when you're doing a for loop, you got some compares going on each fucking time. While you're doing the recursion, it's just plug. I guess we still got the Fn equals 1 thing.
We're gonna count it.
What?
We're gonna count it, or-
Count what?
For the comparison, is that what it is?
Not yet. We'll do that later. Different module.
Nothing.
Not there yet. That's when we start looking at big O notation and other shit like that. Any questions? All right, what do we got scheduled? What else do we got scheduled? We're still doing this shit tomorrow, or Wednesday, talking about arrays. And the arrays chat is short. But I guess we can start talking about it now. All right. Arrays. Do I have anything good on a module on arrays? I'm gonna copy and paste. God damn it. Not really. I think this was just blank. There's no lab in it. All right, limitations of regular C-type arrays. Let's come take a look at that. So I'm going to comment this out for now. Is everyone good to continue? We'll uncomment that when I copy and paste it. Did I copy and paste it fucking last time too? I didn't. I didn't do what I did on Thursday night. I gotta put that up here still. I'll post the announcement for that. Back to what we're doing. So limitations of arrays. Let's say we got an array. Let's call it R because we're lazy. R. It's a pirate array. And we'll make our AR0 equal 1. AR1 equals 7. AR2 equals 13. So right now we are exploring the limitations of arrays. So here we've got indices, which is plural for index of 0, 1, and 2. And array size 3. And we can do a quick see out. Array 1. Shit you've known how to work with for a while. You're just setting up an array. So maybe wanting to look through them one at a time. Should do a for loop instead. Which means I should make this a size thing. And size equals 3. And change this to size. Do doesn't like that. Why doesn't it like that before I put my cursor over it? Const. Arrays need to be a constant size. So that sucks. Arrays can't change size at runtime. WTF. Lame. Fucking Reddit. You know what he says? He says WTF, and then you know what he follows that with? Has anyone taken Reddit? Wow, that's fascinating. Now, all right, so we're doing a loop. So int n equals, we'll start at 0, n less than size. N plus plus. CRA n. Is this going to work? Let's see. Maybe let's add some more shit to it. There we go, make it nice and pretty. All right, so we got what we want. So what if I said n less than 5?
Then you should get it now. Because it's not 5.
Are we gonna get an error? Who thinks we'll get an error? Who thinks it's gonna tell me to go fuck myself? Does anyone think anything different?
It's not filled with junk values.
The other option is it could fill it up with junk values. Right? Let's see what happens. Junk values. So something key to note about computer software, when you delete shit, you don't delete a goddamn fucking thing. You are deallocating memory. The shit's still there, you just don't have a way of accessing it directly. But the stuff's still there until you write over the memory. So whatever it was in that memory block ahead of time is eating up, we're getting the value there. I don't know what that is. So this is yielding, let me put it in a for loop. If we go outside the array, past the end of the array, we start accessing old data that was stored there, and it produces meaningless, let's call it red and talk. Meaningless stuff. Oh yeah, you were there because you fucking went over and sat with Redden.
He came to me. He came to me.
And you went with him. All right. What else do I want to say here? Maybe let's look at their address. How do I get the address here? The ampersand sign, array n, right? And that's going to give us fucking hexadecimal. And what do we say to hexadecimal? Fuck you, hexadecimal. You can go die in a fire. Hexadecimal is not, you know, there's a class here that teaches you how to read hexadecimal. Do they do it in CS5? Math 5 does it too. Or Math 10. Mathematics for elementary school teachers. And you're like, why the, right? So it teaches you how to add in Babylonian fucking numeral systems, all sorts of shit, because the idea is you all take for fucking granted how you add. You've known it. Can you fucking explain it to a fucking 4-year-old? It's not as easy as you think. So the idea is force the students to go through learning a whole bunch of new fucking numeral systems and how arithmetic works. As adult, there are adults in the class now learning it, and you can study the process of how it's learned, and so that you can better teach our basic base 10 number system. But they do cover hexadecimal and other shit in there.
It's funny you mentioned that because the only reason I know how to do hexadecimal is because there was like a puzzle horror game that involved that. That was like the main premise. And
Really?
Yeah.
If you can do it with binary, it's the same thing, except the values don't go 1 and 0 and 1. They go 0 up to 15. And since we can't do numbers for 10 through 15, they add A through F. So what else did I want to say? Okay, so
It gets some weird stuff the higher we go. So like if you think for the next say 100 numbers, get 0, you get 5 or 11.
What are you talking about?
Can you set like for the folder? Can you set it to like limit of 100?
Yeah, let me finish typing shit. Deleted files aren't deleted, they are deallocated. For people that go visually rather than off what I'm saying, the memory is deallocated. But the shit is still there. It's like moving out of a house. It's like abandoning a haunted house. No one lives there, but the house isn't gone. Just because no one resides there doesn't mean there's a vacant plot. So there's shit still there. I don't know if that's a good analogy. I came up with that right now. So maybe like a haunted, I don't know how you deal with a haunted fucking house. Like a haunted house, you have to build a new house over it, crushing the previous house. I don't know. All right, so you wanted me to do n to 100, right? Some of them I got 0 and 1 stored. I got a lot of zeros stored. -1. I see a lot of 3270 764s. I wonder what that is. We can see that these are all exactly 4 apart, which should be the case because they're integers.
And you get like 26, like on 55 and 56.
So why is that the case? Because as we use memory, we're using memory of different sizes. All the programs we run are different sizes. So like, let's say we have 100 boxes in a row. The first time we fill up the 100 boxes. Next program we run, we only fill up 75. So we got 75 Bs and then 25 of the As, the originals. And then we do it again, and maybe we have 20, and now 20s are Cs, and the next 55 are Bs, and the next 25 are As. And we get all shits of all different sizes, and each thing from each different thing is storing different things. So it's the way memory is saved. It sucks. This is another problem though. What we just saw, we saw with the address that it's storing in sequential or contiguous memory, which means fucking sequential, which isn't that bad for a small array. But like, what if we had like a multi-dimensional array where we're storing fucking like a database of fucking COS students? There's like 15,000 students. We want to keep old students' data. So I don't know how many fucking students we've had over the that adds up. And if we want to store like people, that doesn't work well either, because you're adding new people all the time. And we have a fucking fixed or constant size. So arrays suck. And they suck even more when you try to delete shit from the middle. So I'm going to put this deck down to n equals size. And maybe I'll make it a little bit bigger. And I'm going to make it size 5. All right, so I made it a little bigger. Let me pause and let you get caught up. Because let's delete the contents of array 3 or array 2. Okay, array 1. So can I say array 1 equals null? And then I will do this for loop again. Get rid of the fucking second round of jibber jabber. Let's put in a CL with some spacing. They don't like something. Where is it at? Says it's at line 44. Why is it stuck at line 44? Let's end it, try it again. I don't like it. Is it simply because I said no? Yep, it's because I said no. Okay, so making it null doesn't really work. Do I want to set it to 0 though? So like set it to A. Oh. Like that? God damn it. Quit fucking trying to think that you know what I want. Like that? Is that what you're talking about? Let's try it. It ran. Okay, but it said it's a fucking 0. In an array, the whole is integers. Is this ideal to have a 0 in the middle of an array? No. So set the value to 0. Not ideal in an integer array. So maybe we want to like move everything up. Maybe we should do a for loop where n equals 1. We'll start with wherever our bad index is. And we'll say I less than size. I plus plus. Nope, we don't want to go all the way to the end because we're trying, what we're gonna do is we're gonna say array I. If we want to move everything up, we should do array I equals array I plus 1. And if I make the size go too large, that shit looks terrible. And after that's done, we kind of have to say array size minus 1 equals 0. We're gonna have to have this, we can do the 0 at the end, but we'll just know that any zeros at the end of array represent deleted things. Where a 0 in the middle of an array means like that motherfucker had a 0. Like if these were bank account balances. Does that make sense, what we did there? So each one of these. What did I call them? 1, 7, 13, -2, and 168. And as I did it, this is R1. So as we did it, we said, this is now 13. And this is -2, and this is 168. This was the for loop. And then after the for loop, we said R size -1 equals 0. And it's going to store 0 there. Now our zeros at the end. This gets tedious, and it's 6 o'clock. So we'll go further into better things we can do. And that's why we're eventually leading to pointers and more fun shit.
Can we just use it?
Yeah, we're gonna look at vectors.
Slow down a little bit.
Don't forget Juan's here till 8. You guys are working on shit. It doesn't even need to be CSCI 1 or CSCI 2 if you're taking a class with him in another class. You want to. The room is empty.